So in this video, we're going to talk about how the pH scale originated, and we're also going to talk about how to calculate the pH of bases and the relationship between pH and equilibrium. It's going to be pretty neat. I think that a lot of students have some idea of what the heck is going on with pH scale from 0 to 14, which isn't entirely correct, but and so this gives you some of the basis for what the pH scale is. So let's look over here in the presentation. Okay, so remember that water autoionizes. Okay, H2O plus H2O is in equilibrium with H3O plus OH minus. Okay, now that's important because let's keep in mind that these two things are liquids. So because this is in equilibrium and it doesn't completely ionize, it's not strong, we can write an equilibrium expression for this. And so we can write that K equals, again, products over the reactants. So it's the concentration of H3O plus times the concentration of OH minus. Now, this has a special subscript that's a W, okay? So, KW is measured to be, or was calculated, was determined to be 1 times 10 to the minus 14. Now, very quickly, you in there, student, when you put this in your calculator, make sure, okay, this value that I am trying to point at on the thing here, this value right here, when you put it in your calculator, you type 1 E 10 to the minus 14, or put it in parentheses 1 times 10 to the minus 14. Okay, you don't want to skip that this is 1, that 1 there. Okay, that's very important. Okay, anyways, okay, but I digress. Now, let's evaluate this statement. Okay, why is it that the concentration of hydronium ion equals the concentration of hydrogen ion? Well, this is an equilibrium. For every one of these, we get one of those and one of those. So the concentration of this and this are equal at the end. And so if we know that the KW of water is 10 to the minus 14, we know that the concentration of H3O plus is half of that, and half of that is 10 to the minus 7. Okay, now here's where it gets awesome. What is the pH of water? Well, pH equals the negative log of the concentration of hydronium ion, or hydrogen ion. And so that means that the pH equals 7. And this is where we get the neutral, okay, right down here at the bottom. This is where we get the neutral value that water is at 7. It's the basis of the pH scale. Okay. Now, that's what we have here. Okay. Now, if you have more hydronium ion, so the concentration of hydronium ion is greater than 10 to the minus 7, that means that it is an acid, okay? And that means that the pH value is less than 7, okay? If it's basic, that means that you have a concentration of hydronium ion that is that is less than 10 to the minus 7, and therefore the pH value is greater than 7. Okay. Now this sets up something very interesting. Okay. What we can do is if we understand the formula that pH equals the negative log of the concentration of hydronium ion, we should also be able to see that because water is in equilibrium between hydronium ion and hydroxide ion, we should also understand that we can calculate something called pOH. And when it's neutral, pOH is equal to the negative log of the hydroxide ion concentration. And when you have the negative log of the hydroxide ion concentration, when it's neutral, remember the hydronium ion and the hydroxide ion is the same. So that the concentration of hydroxide ion is 1 times 10 to the minus 7 in water. And that makes it neutral. And so that means that the pOH is equal to 7. Okay. Now, a very quick aside, anytime you have p, that lowercase p in front of a value, that means take the negative log of it. Okay. So we may talk about pKa, okay, which is equal to the negative log of the Ka, okay, equilibrium constants. Okay, we may talk about pKb. pKb is the negative log of the concentration. Sorry, it's the negative log of the Kb, of the base equilibrium constant. Okay, so it's kind of neat how all of this kind of interrelates. So now we have pH and pOH. Okay, and so now summarize those statements which we talked about. Now, this is where it gets really cool. Okay, this is what we know, okay, from equilibrium, that the concentration of hydronium ion times the concentration of hydroxide ion equals Kw, and somebody once calculated that. Okay, let's see if I can get that to pop back up here. It's going to go through the whole thing. Okay, now let's do some math. Okay, so I'm looking down here. Okay, what we can do is we can take the negative log of this and the negative log of this and the negative log of this term. And so when we do that, the negative log of 10 to the minus 14 equals 14. The negative log of Kw is this. Okay. And remember, when we take the negative log of two terms that are multiplied together, you add the two terms separately. So the negative log of the hydronium ion, isn't that just a fancy way of saying pH? And then the negative log of hydroxide ion, that's a fancy way of saying pOH, equals, well, the negative log of Kw is equal to pKw, which equals 14. And what's the scale that we use for the pH? It's between 0 and 14. Okay, not a coincidence. Okay, so typically we just go from here. And so now what this does is this gives us a way to interconvert between the acids and the bases in terms of finding the pH. And so let me show you what I mean by that. Okay, let's go here. Let's go here. So let's try to find the pH. Find the pH of 0.020 molar sodium hydroxide. Now, this is a strong acid, or strong base, excuse me. Okay, so I'm looking right at it here. And so that strong base, well, we should be able to figure out what the pH of it is. Now, the chemistry can be a little strange, but follow me on this, okay? Watch what happens. Okay, what we know is that sodium hydroxide, okay, what we know is that, let me try to get this figured out here. What we know is that sodium hydroxide, when it goes into water, completely ionizes to give us Na plus OH minus. And we also know that the concentration, because it's strong, it completely ionizes, it completely dissociates. We know that the concentration of the hydroxide ion is 0.02 molar. Okay? Well, from this, can't we calculate a pOH? Sure, the pOH equals the negative log of the concentration of the hydroxide ion. Okay, well, and so that means that the pOH is negative log of 0.02, which is 1.70. Okay, now that's the pOH, but we need to figure out what the pH is. Well, we know from this thing, that pH plus pOH equals 14. And so while the reaction doesn't produce any hydronium ion, because there's water going on there and water is doing whatever it's doing, okay, pOH, we can go from here and we can say that the pH plus pOH equals 14. Do we have the pOH? Sure. 1.7 equals 14 pH. So that, when we do that, let's say, so we get pH equals 12.3. And that's a basic pH. So here's what I'm going to do. I'm going to set up, I guess, a pH box, okay? So the pH box shows us how we're relating all of these values so that we can easily interconvert between pH, pOH, hydroxide ion, hydronium ion, because it's not necessarily straightforward, okay? So let's start by putting pH here. Now, we can easily go to pH and interconvert between pH and pOH using the relationship pH plus pOH equals 14. Okay? That allows us to interconvert between there. And we also know that, and let me get rid of my mug, okay? We also know that we can interconvert between hydronium ion concentration and pH using the relationship pH equals the negative log of the concentration of the hydronium ion. Okay? And we know that we can interconvert between pOH and hydroxide ion concentration using pOH equals the negative log of the concentration of the hydroxide ion. And lastly, we can interconvert between hydronium ion and hydroxide ion using Kw. And so where we have Kw, which is 10 to the minus 14, equals the concentration of hydronium ion times the concentration of hydroxide ion. Sorry for squeezing that in there. Now, notice what you can't do, and I'll do it in red because you can't do it. You can't go directly from pH to the concentration of hydroxide ion. No, 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 you can't do that. You'll either have to go, and I'll do this one in green, okay? You'll either have to go to pOH and then the hydroxide ion, or you'll have to go to hydronium ion and then down to hydroxide ion, okay? And the same is true for any of these corners, okay? And so what this does is this allows you, it gives you like a roadmap to be able to interconvert between pH, pOH, hydroxide ion, and hydronium ion. You can just keep going around and around and around. It's just a neat tool, kind of a pictorial device that helps you figure all of that out. So hopefully this will help you calculate the pH and of bases, and have fun doing all that stuff.